Okay, so it says which of these following quantities could be represented by a continuous function of time, and which have more than one discontinuity. So let's take a look. Velocity of an airplane during flight. I'd say continuous function. Let's look at the answer. The velocity of an airplane during flight from Boston, they give an example, a continuous function of time. It is. Let's do the next one. Temperature for room under ordinary conditions. And room temperature is also continuous. I would expect that, right? We don't expect any jumps in temperature. They gradually go up or down. So temperature of room under ordinary condition is continuous function of time. Let's do the next one. The value of a bank account with interest paid yearly. Now that's an example. If interest is paid yearly, is an example where the money, provided you're not taking money in or out, the money's going to be constant throughout the year, but then at the end of the year, it's going to jump up. So there's going to be a jump discontinuity there. So let's say the value of the bank account and interest paid yearly is not continuous. What's going to happen when you get the interest payments or deposits or withdrawals, things are going to start to jump around. Let's do the next one, and the salary of a teacher. Now the salary of a teacher, for the most part, is going to be, for some teachers it's continuous, it just never changes. For other teachers, it actually could do one of two things. It could jump up and get a raise, or it could jump down and you get a deduction in wage, all right? And that does happen where teacher salaries are either pushed downward or pushed upward. So this is an example of a discontinuous function. So salary of teacher is not continuous function of time. It has discontinuities, whether the teacher gets a raise, or when I say a raise in salary, or sometimes a decrease in salary. It does happen. Let's look at the last one, the population of the world. The population of the world is so large, it's seen as a continuous population. However, it's really discrete. And what I mean by that, it's either jumping or declining by a number. What's a number? A death would be an increase of 1. That's a jump. A death would be a decrease of 1, and a birth would be an increase of 1. However, it's almost always modeled as a continuous function. Let's take it because it's so large, by the way. The population one is not continuous function of time since it changes by a discrete amount, which each birth and death, all right? Since it takes on such a large number, many billions, it really is, it's often treated as a continuous function and for purpose of mathematical modeling. A lot of functions are not continuous, but we model them with continuous functions, by the way. They sort of have a correspondence between the two. But again, although population is not continuous, it's modeled with a continuous function. Thank you.